talk ratios and proportions. So a ratio is two numbers compared to each other with division. A proportion is an equation stating that two ratios are equal to each other. So we'll basically do two fractions with an equal sign in the middle. It's an equation. It's still an equation because it has an equal sign in it, but it's saying that these two fractions, these two ratios are equal to each other. So we can solve a proportion by using cross products. So we can do our extremes multiplied together, and that should be equal to our means. So I can do my 12 times 3 and my n times 8, and that will give me an equation that should help me solve for my variable. So in this equation, we end up with 12 times 3 equals n times 8. We're still solving for n now. We have our typical looking equation. We're going to do our math on the left side. 3 times 12 equals 36. On our right side, we have 8 times n. We want to get the n by itself. Let's divide by 8 on both sides. We end up with n equals 4.5. We'll see equations that have, proportions that have more complicated numerators or denominators to them. You'll also notice that this really could be just an equation that has fractions in it. So a lot of times we see equations that have denominators in it, and I know how much you guys love fractions. So thinking of it like a proportion is another nice way to help you get rid of the denominators very smoothly, so that you can, instead of working with an equation that has fractions in it, you can get rid of those fractions in one fell swoop. So think about it like a proportion. So for here, we want to think about this numerator as one expression. It's x plus 4. That x plus 4 needs to go in parentheses. So we're going to do x plus 4 times 4. Again, don't forget that that numerator is one whole expression. It's not x plus and then 4 times 4, or 4 times x plus the 4. We need to multiply that whole expression by 4. So we have x plus 4 times 4, and then our means are 12 times 3. Using our distributive property here, we have 4x plus 16 equals 36. Subtract 16 from both sides, the left and the right side, we end up with 4x equals 20. Divide by 4, we end up with x equals 5. And if we do a quick mental math check with that, we can see that that makes sense. So we come up with 5 plus 4 is equal to 12. It's equal to 9. 9 over 12 is equal to 3/4. When I simplify 9/12 down, it becomes 3/4. If we also use our cross products, we have 9 times 4, which is 36, and 12 times 3, which is also 36. So our basic solving proportions. We can use proportions to help us solve some real world problems where a ratio makes sense to use. So let's take a look at two word problems that we might see. Trent goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. At this rate, how long can he ride in 6 hours? So again, this is a word problem. They haven't set it up first, so I'm going to define my variable. I'm going to use m for miles. My ratio that I'm going to use here, I'm going to put miles over hours. So I want to make sure that in my proportion, I've got miles in my numerator and hours in my denominator as I work through that. Each of my ratios, one ratio at a time, should kind of represent the different situations that I have. So for Trent, he does 30 miles in 4 hours. So these two belong together in one ratio. And then my other ratio is that unknown amount of miles that I'm wondering about in this 6 hours that we're kind of presenting as our, as that we wonder what would happen in 6 hours. So how many miles in this imagined 6 hours that he might do. So here's my proportion that I have set up now. Now I can just go back to solving it using cross products. 30 times 6 and 4 times m. Again, my extremes are equal to my means. The product of my extremes equals the product of my means. So 30 times 6 equals 4m. We go through and solve this, and we end up with 45 miles. So Trent should make sense too. If he can do 30 miles in 4 hours, 45 miles in 6 hours makes sense. And our last word problem. In a road atlas, the scale for the map of Connecticut is 5 inches equals 41 miles. What is the distance in miles represented by 1.5 inches on the map? Again, I'm going to define my variable. I'm going to use d as the actual distance. We have the distance on the map, but then we actually have the distance in actual Connecticut. This is the ratio that I've chosen to use. I'm going to put my scale over my actual distance. So my numerator will represent a measurement on the map. My denominator will represent my measurement in real life in Connecticut. So 5 inches on the map is 41 miles in my real world. Yes, these are different units, but that's okay because I'm going to use them in a ratio just to compare the numbers themselves. I'm going to set that ratio up the same way in the other half of my proportion. So 1.5 is on the map. I'm wondering about that mystical D, miles. That might be in the 1.5 inches between towns on a map as I measure. So once I've set this up, I'm going to use my cross products to help me solve for D. The product of my extremes, 5 times D. The product of my means, 41 equals 1.5. We're going to set those equal to each other and then solve. So I end up with 61.5 equals 5D. Divide by 5, end up with 12 3/10 miles. So 12 3/10 miles is the actual distance between those two towns, if that's what I'm talking about, on a map, if it measures 1.5 inches on the actual map. Which, again, if we go back and check the reasonableness of our answer, if it's 41 miles for 5 inches, it should be less than half of that for 1.5 inches. And yes, that makes sense.